All right, people, here we go. So we've been playing mostly with like polynomials, right? X cubed, 3x squared, all that kind of stuff. But we can use other functions as well. Okay. We're sticking to polynomials because it's the easiest way to get used to it, right? But um, there are derivative rules for all sorts of other functions, right? So e to the x, right? The derivative of e to the x is kind of cool. It's itself, it's e to the x. So a natural exponential just does that, right? Derivative of a to the x, so like 3 to the x or something like that. So the derivative of that is just itself, right? Kind of like the one above it, but then you multiply it by the natural log of whatever the base is. Okay. So this actually applies here too. You could do this e to the x times ln of e. ln of e is just one. So it's just e to the x. Okay. It's kind of cool how it works out. We're going to get one of those down here. Okay. The other two get kind of nasty. Um, so I think if you got used to two of them, these would be the two. All right. For trig functions, we've got sine, cosine, tangent, cosecant, secant, cotangent, right? The three biggest ones obviously are sine, cosine, and tangent. You see those all the time. We won't be playing with them as much or very much at all, but when you get to calculus later on in your next class, you will see these a lot. And they're pretty easy to memorize. Sine turns into cosine. Cosine turns into the opposite of sine. That's something you have to remember. And then tangent turns into secant squared. Okay, you'll see tangent and secant are buddies in a lot of ways. All right, logarithmic functions. Natural log of x is just the derivative of natural log of x is just 1 over x. It's kind of cool. And then we have, if it's inside, if we have a different base than e, this is what we've got. We've got 1 over x times ln of a. What does that remind you of? Yeah, it reminds you of this exponential, kind of the same thing. Remember, exponentials and logarithmics are just inverse functions of each other, right? So probably reason why that they're in common here. So that's kind of cool. So I'd say this one and this one are good ones to eventually have memorized, right? The inverse trig functions, you'll eventually maybe come across a class where you have to memorize them. But the big ones are those two, these two, and these three in a calculus class, in your next calculus class. Those are ones you're probably going to have to memorize. And depending on the teacher, depending on the level, you may have to memorize more. But those are the seven biggest ones that are there. All right, cool. So let's try it. Let's try a few. So if y is equal to 3 to the x, find y prime. So that's going to be this rule. It's not e to the x, it's some base to the x. So when we find the derivative of 3 to the x, so y prime is equal to d dx of 3 to the x. Oops, sorry. Y prime is equal to the derivative with respect to x of 3 raised to the x power. That's going to be 3 to the x times ln of the base itself. That's it. 3 raised to the x times the natural log of 3. That's it, right? There we go. And this tells us the slope at any point of this, right? 3 to the x is this, right? And the graph of this, right, will give me the slope of this at any point. Cool, right? Cool. All right, this one we've got a little extra funk. We've got adding. So y prime, the first one's going to be easy, right? Same rules before. Some are different. It's just going to be 2x, but plus ln of x, right? So the rule is we find the derivative of this. We got that. We need to find the derivative of ln of x. So let's come over here. The derivative of ln of x is just 1 over x. That's it. We're done. Not too bad, right? Especially when you have them written, right? All right. Now we've got some fun. As soon as I see this, I should think what rule? Quotient rule. Okay. Quotient rule. I might even write it down, right? Okay. So what is the quotient rule? It's low. So f prime of x equals the low times the derivative of the high. So what's the derivative of sine of x? Cosine of x. Minus So low D high minus high, which is sine of x. Sorry. Low times the derivative of the high minus the high, which is sine of x, times the derivative of the low, 2x squared. Low D high minus high D low. And then what do I do on the bottom? Square the bottom and off we go. X cubed squared. So that equals x cubed cos of x minus, I'm going to put that 2x squared in the front, 2x squared times sine of x divided by x to the sixth. I could simplify here again. If this is AP calculus, you can leave it like this. You don't have to simplify, right? It's a good idea. I could take an x squared out of both of these. So I'd get x cosine of x minus 2 sine of x over x to the fourth would be the simplified version of that. Cool. Cool. Okie dokes. Cosine, and then on the inside, 3x to the fifth. What does that remind you of? That's chain rule. Okay. Part of the fun of calculus, you're like, yeah, fun, Mr. Rebuff, great, is seeing patterns, right? Pattern recognition. I see a fraction, so I think quotient rule. I see something stuck inside of something else, so I see chain rule immediately, right? Or at least I think that. Okay. So kind of pattern recognition here. So chain rule says, right? I take the derivative, or I need to find the inside and the outside, right? So g of x is going to be my inside. What's inside? That's 3x to the fifth. What's outside? That's cosine of x, right? So I take the derivative of the outside. So what's the derivative of cosine of x? So come up here. The derivative of cosine of x is negative sine of x. So I'm going to go negative sine of the inside, 3x to the fifth of g of x, times the derivative of the inside. That's going to be 15x. Okay. I would switch this around a little bit. I'd go negative 15x sine of 3x to the fifth. And there is my answer. Cool. Cool. So now we've branched out, right? It's not just polynomials anymore. We can play with other trig functions. And again, I would limit my questions to those 7 types, probably right there. I wouldn't get into real funky stuff for you. No inverse trig functions. I remember not loving those very much, but you get used to them, right? And memorizing them, there's little tricks, but I'm not even going to get into that because we don't need to. You got this right here for every quiz, every exam in my class. So that's that. Good job, people. See ya.